at matrices, in particular multiplication. So we have AB and we have to find out what is CE. So let's deal with part one first. AB. So this is A, which is, and B. All right, so we have A here, and then we have B across there. So that's the first thing we have to do. You don't have to put a multiplication sign. This is understood right here. Now we have to determine what is the size of the matrix. All right, what is the size of the matrix? Size of the matrix is like row by column. All right, so there are 2 rows and there are also 2 columns on the matrix A. So since there are 2 rows and 2 columns, this matrix will be a 2 by 2, because you have to say row first times column after. This gives you the size of the matrix. So there are 2 rows and there are 2 columns. So the size of this matrix A is a 2 by 2. Same with B, 2 rows, 2 columns. So B as well is a 2 by 2 matrix. Remember, rows first, columns. Rows are what's going across, columns are what's going down, right? So the second thing I tell students to do is put the size of both matrix. So this is a 2 by 2. And that is a 2 by 2 right here. All right. Now, you have to do this observation. The last number must be equal to the first number. So the last number in the first matrix must be equal to the first number in the second matrix. So because we have a 2 here and we have a 2 here, it simply means that the matrix, both matrices can be multiplied, right? So the last number in the first matrix must be equal to the first number in the second matrix, right? And the result, right? The first number in the first matrix, right? Which is 2 multiplied by the second, by the second number in the second matrix. That gives you what size your answer will be. So when you get your answer, the size of that matrix is supposed to be a 2 by 2 matrix. All right, so let me just repeat that quickly. The first number in the second number in the first matrix must be equal to the first number in the second matrix. All right, so these 2 numbers here must be the same. 2 is equal to 2. And the outer numbers, so the first number in the first matrix and the second number in the second matrix, that will give you what is the size of your answer. So whatever answer you get, it's supposed to be a 2 by 2 matrix. Continuing, we have here, I like to say row by column. So this first matrix we are dealing with the rows, and the second matrix, we are dealing with the columns. All right, first matrix we deal with the rows, second matrix we deal with the columns. So let's deal with, I'm going to deal with this and this. All right, so I'm going to deal with this row and this column. Let's deal with that one time. So I have here, so remember row by column, that we are going to get this position here. So I have 11 by, so the first number with the row is, you're multiplying that by the first number with the column. So 11 by 1, right? 11 by 1 plus, always plus, the second number in the row, we multiply that by the second number in the column, -1 by 2. So we have -1 by 2. So you could put the numbers in a bracket, right? You could put the numbers in a bracket. So we have first with first plus second by second. So 11 by 1 plus -1, we're going down by 2, right? That's this position here. Let's deal with this position here now, right? So we are going to deal with this row and this column. Before we dealt with this and this, that's how we got this first position. Now we are going to get this position here. We're going to deal with this row and this column. So let's deal with that. So we have, remember, going across and going down. First number here with the first number here. Going across, second number here, going down with the second number here. First with first, second with second. So we have 11 by 3 plus, remember to leave a little space, right? You don't want the matrix jumble up. So 11 by 3 plus -1, and we're going now by 0. Close the matrix bracket here. So far we have this, the first two. We just need the last two, right? The last two. Let's continue. Now we dealt with the top. We dealt with this and this, which gives you that, all right? We dealt with this and this, which gives you that, right? This row, this column to get this piece here, this row, this column to get this piece right there, all right? So let's deal with that. So row by column, first with first, second with second. So we have 7 by 1, always plus, 0 by 2. Right, so the first in the row is 7, the first in the column is 1. The second in the row is 0, the second in the column is 2. 7 by 1 plus 0 by 2. Right, we have that here. Remember, always plus in the middle. Now we're going to deal with the last one, which is this last space here. We have 7 by 3. Let me just reiterate. We're going to deal with this here and get this position. So we have 7 by 3. Always plus, so 7 by 3 plus 0 by 0. All right, so 7 by 3, right? First with first. Then we went across, we have 0. So 0 by 0, because when we went down, that spot. All right, first with first, second with second. So if I do this and I do this, first, 1, 2, 1, 2. So first with first, second with second. All right, so the first number is 7 multiplied by 3. That's what I have here. Plus, always plus, 0 by 0. Now, once you do that, you just simplify, right? This is simple computation. You just simplify and you get your answer. You could use a calculator, right? You could use a calculator where you can work it mentally, all right? So we know 11 times 1 is 11. -1 times 2 is -2, right? So 11 plus -2 is 9. All right, if you apply a calculator, you'll get 9. So the first position is 9. All right. 11 times 3, we know we have 33 here. -1 times 0 is 0. 33 plus 0 is 33. Our answer is filling up nicely here. 7 times 1 is 7. 0 times 2 is 0. 7 plus 0 is 7. And 7 threes are 21. 0 times 0 is 0. So 21 plus 0 is 21. I'm gonna write this 7 a little better than that. All right. Now, this right here is the answer. Right here. Row by column. All right. So just to quickly recap, the first thing you do, you write on the matrix. So this is E, and this is B, right? The second thing you do, you state what is the size of the matrix. So matrix A, row by column, 2 rows and 2 columns. So there's a 2 by 2, this is a 2 by 2. Then you check to see, okay, if the numbers are equal. So these two numbers here are equal. We know the matrix can be multiplied. And the n numbers give you the size of the matrix. So if this is a 2 by 2, your result's supposed to be a 2 by 2. So let's check. We have 2 rows and we have 2 columns. So this result here is a 2 by 2, correct? And then row by column. So first with first, second with second. So 11 times 1, that's what I have here, -1 times 2, right? You always plus it in the middle. So 11 times 1, all right, plus, always plus, always, right? Always plus. So 11 times 1 plus 2 times -1 times 2. And when you do that and you simplify, you get your result. Let's take a look at the second one. Let's take a look at the second one. So we have to find out, what is CA? So we write down C first. C is -5, 6. And A is 11, -1, 7, 0. All right. Remember, you write down what C is, write down what E is, and then you check to see what was the size of the matrix, right? Or both matrix. This first one, we have 2 rows and we have 1 column. So we know that this is a 2 by 1. Remember, rows first, column afterwards. So this is 2 rows, 1 column. This one here, 2 rows, 2 columns, right? We have 2 rows here and we have 2 columns. So this is a 2 by 2. Now, since the numbers in the middle here, these 2 numbers are not equal, right? No solution. Right, or the right or the whole good. This is no solution. This means solution. No solution. Since these 2 numbers are not equal, no solution. All right, we could try to work it out, but it will not work out. Because if you see, let's try to work it out for, right? If you see row by column, all right, so we have -5, right? -5 by 11, plus we do have a number here to multiply by this number below here, because we have 2 numbers here. We're going across, we have -5 first with first, but we don't have any second with second, right? So that this matrix here cannot be multiplied. So, you know, you don't have to do all that. You don't have to do all that. Once you know that these 2 numbers are not equal, can't multiply the matrix, no solution. Once you do this, you're correct, all right? So that's it, that relates to matrix multiplication.